Hello students, myself Rekha. Today we will do class 9, chapter 1, number system lesson, exercise 1.3, 6th question. See beta, look at several examples of rational numbers in the form of P by Q. Q is not equal to 0, where P and Q are integers with no common factor other than 1 and having terminating decimal expansions. Can you guess what property Q must satisfy? This is the question. What given here? We have to take several rational numbers. We will take, I am taking here 3 rational numbers, not only 3, 4, 5, any rational numbers you take it. Here what is there? That rational number should be P by Q form. Rational number means it is in the P by Q form. Q is not equal to 0. P and Q are the integers. This is the rational numbers. How to take this rational numbers means here, no common factor. Try to understand. No common factor other than 1. No common factor other than 1. This numerator denominator common factor should be 1. See here, 33, 8. This is not divisible by other number. Only it is divisible by 1. So you have to take that fractions. How to take no common factor other than 1. So how to take this fraction? Only that two numerator number, denominator number divisible by only 1. Okay, here also see these two numbers 329, 400, it is divisible by 1. That's it. Other number it will not divisible. This is also will take. How to take these numbers? No common factor other than 1. These two numerator number, denominator number, common factor should be 1. Common factor should be 1 means it is divisible by 1 only. And having the terminating decimal expansion. These two you divide means you want a terminating answer. This divide means you will get this answer. This divided means you will get this answer. So this is a terminating decimal expansion. And having you want a terminating decimals, so terminating decimal fractions only we have to take. Can you guess what property Q must have? You have to write it. So I am taking here 3 fractions. How I am taking 3 fractions? These two common factor should be 1. Again, what is there? That fraction should be terminating. Divide means remainder you want 0. Terminating. This fraction should be terminating. Last you have to find. Can you guess what property Q must have? You have to write. See your first number I am taking 33 by 8. 33 by 8 common factor what is there? 1 is there. And this is the terminating decimal. Answer what is there? This divide means 4.125. This is also I am taking common factor is 1. And here what is there? This is the terminating. Total answer 0.8225. And this is also common factor is 1. And this is also terminating fraction. So here what is the question? These qualities using only we will take the fraction. After taking what is there, finally asking what? Can you guess what property Q must have? Q property what must have? You have to find. So see here Baba. Here down I am taking 8. See here 8 taking means 8 is divisible by 2. You take here 2 4s are 8. Again 2 2s are 4. 2 1s are 2. So 8 is equal to what is there? 2 into 2 into 2. Here what is there? It is a 2Q. Next come here denominator Q what is there? 400 is there. 400 we will divide. Here see Baba. 2 2s are 4, 0, 0. Next again to take 2 1s are 2, 0, 0. Next to take 2 5s are 10, 0. Now again 2 possible. 2 possible means 2 2s are 4, 1 remain, it is 10, 2 5s are 10. Again what is there? 5 5s are 25, 5 1s are 5. So here what is there? This answer 400 is equal to denominator 400 is equal to what is there? See 400 1 2 3 4. 2 to the power of 4 into 5. How many are there? 2 are there. So 5 square. See here 1 2 3 4s are there. So we can write 2 to the power of 4. 5 2 are there. So we can write 5 square. Next here 25 is there. 25 meaning what? 5 5 is 25. 5 1 is 5. So 25 is equal to what is there? 5 into 5. So it is a 5 square. So here what's here? Can you guess what property Q must have? Q I divided here, this Q also I am taking like factors means. Here observe what is there. Q is, see here you write prime factorization of Q has only powers of 2. Powers of 2. 2 power is there and powers of 5 is there. Here 2 power is there. Here 5 power is there. Here 2 power 5 power both are is there. So this is the what you guess property of Q must have means. Q observe here what is the powers is there Q. This is the 2 power number. This is 2 power and 5 power number. This is the 5 power number. You can write it. The prime factorization of Q must have power of 2, power of 5 and power of 2 and 5 both is there. So like this is there means you will get this fraction should be terminating. See a denominator plus you keep in your mind. Denominator plus 2 power number is there, 5 power number is there and both 2 and 5 power number is there means that fraction should be terminating. You will get only this much answer. So in this sentence you have to understand and write the fractions. This qualities write the fraction. What is this Q must satisfy means you write this sentence only. That's it. Now 7th question. Write three numbers whose decimal expansions are non-terminating, non-recurring. We have to write 3 non-terminating, non-recurring expansions. Terminating means there is an end. Non-terminating means there is no end. Non-terminating means there is no end. But non-recurring, which numbers again it will not repeat. Number repeating means it is called recurring. Number not repeating means it is called non-recurring. So we have to write 3 numbers. Any numbers you write. Non-terminating numbers and non-recurring. So I am writing 0.10, 100, 1000, 1 again 4 zeros. So dash dash dash. This is a non-terminating and there is no end and non-recurring. See here 1 0 recurring not there here 1 0, 100, 100, 1 4 zeros. This is the non-terminating and non-recurring numbers. One more you write here 0.50, 500, 5000, 5 1 2 3 4 zeros dash dash dash. This is also again you write one more 0.70, 700, 7000, 7000 dash dash dash. These 3 are the non-terminating and non-recurring numbers. Not only this one, anyone you can write it. Okay. Now 8th question. See Baba, find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. These 5 by 7, 9 by 11 are the irrational numbers. These 2 middle 3 irrational numbers we have to write. These 2 numbers, these 2 are rational numbers. These 2 rational numbers middle and any 3 irrational numbers you have to write the question. See first I am taking 5 by 7, 9 by 11. Answer what is there? First we will find 5 by 7 I am doing here. See 5 divided by 7. 5 by 7 meaning 5 divided by 7. See this is a big number, this is a small number, not possible. So you take a 0 point, here take a 0. So 7 sevens are 49. How much remain? 1 remain. Point is there 0. 7 1 7. Minus means 3. Point is there 0. 7 4 28. How much remain? 2 remain. Point is there 0. 7 2 14. 7 2 14. How much remain? 6 remain. Point is there 0. 60 is there. 7 6 42. 7 7 49. 7 8 7 8 56. How much remain? 4 remain. Point is there 0. Now we will take 7 5 35. See here, minus means 5 remain. Starting only minus is there. Again point is there means again 50. Again 7 7 49. It will repeat. Starting number came means leave it. Okay. Again it will same numbers it will repeat. So this answer is what? 5 divided by 7 means what is the answer? 0.714285 bar. So here I am taking 0.714285 85 bar. This answer is 7 by 4 to 85 bar. Next, which number is there? 9 by 11. See, I am doing here 9 divided by 11. Big number, small number, not possible. So take a 0 point. So 90 you will get. What you will do? 11 8s. 11 8s are 88. How much remain? 2 remain. Point is there? 0. 11 1s are 11. How much remain? 9 remain. See, 9 is repeated. Leave it. Again it will come 88, 88, 88. So this meaning what? 0.81 bar. So this answer is what is there means 0.81 bar. So these two simplified means you are getting irrational numbers, non-terminating and recurring, non-recurring numbers here, non-terminating and recurring numbers, again recurring. So these two are non-terminating numbers only. This fraction simplified means you are getting non-terminating numbers only. So now we have to write what? Find 3 different irrational numbers. These two middle 3 irrational numbers you have to write. This is 71 number, this is 81 number. These two middle irrational numbers we have to write. I am writing 3 irrational numbers are, what are the 71, 81 middle? I am taking 0.71 is there. I am taking 73. See here, 73, 733, 7333, again 7333. So this is which numbers? Irrational numbers. Middle 71, 81 middle is there. 73 middle number only. Next I am taking 0.75. I am taking 75, 755, 7555, again 7555 dash dash dash. Next what we will take? 80 we will take. 0.80, 800, 8000. Again 8, 1, 2, 3, 4 zeros dash dash dash. These 3 are irrational numbers between these two fractions. Okay. Now see Baba, 9th question. Classify the following numbers as rational or irrational numbers. We have to write. See root 23. It is not a perfect root. So which number this is? Irrational numbers. A-T-I-O-N-L. Irrational number. This is which number? Irrational number. Perfect root. Example, root 25 is there. Root 25 means it is answer is 5. So like that numbers is the rational numbers. But root 23 is not perfect root. So this is which number? Irrational number. 225 root. 15 15s are 225. So you will get what is the answer? It is a 15. 15 is which number? Rational number. This is a rational number. Rational number. Next see Baba. Next one what is there? 0.3796. So we can write 3796. See a point after 0 is there. Don't need 3796 divided by point plus you keep 1, 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. 3796 divided by point plus 1, right? 1, 2, 3, 4 zeros. This is what? This is a rational number. So this is a rational number. Rational number. Next. Rational number. Next one see Baba. 7.478478 dash 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 is there. Dash 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 means no end. No end numbers like this anywhere. Dash 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 numbers is there means this is which numbers? Irrational numbers. T-I-O-N-A-L. Irrational numbers. Next, see irrational numbers. Next, see Baba, this is also 1.10, 100, 100, 100, 100. Last bit I explained. So this type of numbers, which numbers? Again, dash, dash, dash also is there. So which numbers? This is also irrational numbers. So any number, dash, 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 like dash, dash, dash is there means irrational numbers only. This is irrational number. This is also irrational number. See Baba, this is not perfect root, irrational number. This is 225, 15 15s. So perfect root, it is a rational number. Not perfect root means irrational numbers. Perfect root means rational number. Next, this is converting if possible. So this is a rational number. Here dash 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 is there, irrational number. This is also dash 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 is there, irrational number. Okay, this is the last sum of exercise 1.3. Again, you have any doubt also comment it and subscribe my channel.